Good morning, guys. Thank you for joining me today for this lesson. If you haven't done so already, please complete your retrieval quiz on your student worksheet and come back for the answers. So pause the video, complete the retrieval quiz, and then we'll green pen. Okay, so the energy needed to start a reaction is known as the activation energy. The collision theories, what we learnt about last lesson in terms of chemical reactions. In order for a chemical reaction to take place, particles must collide with enough energy. When temperature increases, what happens to the rate of reaction? Well, the rate of reaction would also increase. When you add more particles to a fixed volume, you are increasing the concentration. The substance with the largest surface area is sand. If you decrease the surface area, you decrease the rate of reaction. Number 8, the energy given out by a chemical cell is electrical energy. Endothermic reactions take in heat energy, and define the rate of reaction. Well, that is the speed at which reactants form products, the speed at which reactants turn into products in a reaction. So we're continuing with our learning that we started this week. We've already had a lesson on collision theory, so we're going to secure our understanding of the factors that affect the rate of reaction. And we looked at these last lesson. So you need to be able to explain how the different factors affect the rate of reaction. So how, by changing these factors, do they change the rate of reaction? Now, we've looked at these keywords last lesson, okay? So remember, we learned about the collision theory, which explains that in order for a chemical reaction to happen, the particles must collide with enough energy. Remember, we looked at kinetic energy being the energy of movement, the energy of motion, and all particles have some degree of kinetic energy. Rate of reaction, the speed that reactants are used up and form products. Temperature, the degree of heat. Surface area, the exposure of the surface of an object. So remember, we can increase the surface area by breaking something up into smaller pieces. Concentration is the number of particles in a given volume, and pressure is the force exerted on an object. Now, we looked at those last lesson. So just to recap, last lesson we did collision theory. Today we are looking at the factors that affect the rate of reaction. Again, we have already looked at these, but I do want to secure our understanding. So just to recap from last lesson, collision theory. Remember, the collision theory is an idea that helps explain why chemical reactions happen. When chemical reactions happen, the particles must collide. If they don't collide, if they don't bang into each other, no reaction can happen. And when they do collide, they must collide with enough energy. If there isn't enough energy and they just bump into each other, they don't react. And remember, that energy is called activation energy. It activates, it starts the reaction. Then we looked at rate of reaction. So the speed of a reaction, the speed at which the reactants at the start are changed into products. And we looked at the factors that can change the rate of reaction. And we know that a rate of reaction can be increased if we increase the temperature. Remember, if we increase the temperature, we give the particles more kinetic energy. Therefore, they move faster, more chances of collisions, and if they have more energy, they collide harder. Again, more chance of a successful collision. Remember, in order for something to react, the collision must be successful. We can increase the surface area to increase our rate of reaction. we can increase the concentration, we can increase the pressure. So just to look at these in more detail, because you are going to be doing your deliberate practice task on this. Temperature. You need to be able to explain why changing these factors change the rate of reaction. So if we increase the temperature of the particles, it means that the particles move faster because they gain more kinetic energy. Therefore, if they're moving faster, the particles will collide more often. And because the particles have got more energy, when the collisions happen, they happen harder, and therefore they meet the activation energy in order for the reaction to happen. And therefore, our rate of reaction increases. This happens in the same if you decrease the temperature, you decrease the rate of reaction because you're taking the energy away. The particles move slower with less energy and therefore a less chance of successful collisions. Surface area. Again, something we've already looked at, but I do want to secure your understanding of being able to explain why the rate of reaction changes. So by increasing the surface area to volume ratio, okay, means more reactant particles are exposed to the surface. So if there's more surface being exposed to the particles, more particles can collide with the surface. And therefore, if they're colliding more often with the surface, there's more chance of successful collisions and therefore increasing the rate of reaction. So guys, just an image that I should have already showed you. That is sandstone, a lump of sandstone. It's got a small surface area. Now, if we broke that down into and we ground it down into sand, very tiny sand particles, that increases the surface area to volume ratio. So there's more surface area being exposed. If there's more surface being exposed, there's a higher chance of collisions and therefore more chance of successful collisions happening. Concentration. Increasing the concentration of a solution means that we are adding more particles to the same volume of liquid, which means there's less space between the particles, which means there's more chance of collisions and therefore more chance of successful collisions. So you can see in this image here, okay, we've got a low concentration area and then we've got a high concentration. And in the high concentration, you can see that the particles are more likely to collide because they are closer together. So think about this in terms of a classroom. If I've got 10 students in a class, they're less likely to come into contact with each other and they're less likely to collide. Whereas if we increase the number of pupils in that classroom, in the same area, in the same volume, we're actually increasing the chances of collision. Now, we talk about pressure in terms of gases. So increasing the pressure of a gas means that the volume of gas is reduced. Okay, so the space at which the gas particles can move around is reduced, meaning there's less space between the particles, just like in terms of concentration, there's less space between the particles are closer, which means there's more chance of them colliding and more chance of those collisions being successful. So concentration and pressure is all about having the same number of particles but those particles being closer together and therefore more chance of collision. So your first task, I would like you to go to your student worksheet, click the link for task 1 to watch the video on factors that affect the rate of reaction. You may make notes throughout the video because that might help you with your next task. But if you don't want to, because you understand it, you can just watch. Okay, so task 2, collision theory and rate of reaction poster work. So I want you to create a poster or a fact file with bullet points. If you don't want to produce a poster, that's fine. You can create a fact file on the collision theory and the factors that affect the rate of reaction. Now, what you'll need to include is a definition of the collision theory, a definition for rate of reaction. You then need to list the factors that affect the rate of reaction, so temp, surface area, concentration, pressure, and then I want you to describe how increasing each factor increases the rate of reaction. So I don't want it just listed. I want you to explain why increasing them increases the rate of reaction. Now remember, you need to think about kinetic energy, collisions, activation energy, and the successful collisions. So pause the video, complete this task. This task could take you 20 to 30 minutes. Okay, so that brings us on to our consolidation. If you worked on paper to complete your poster or your fact file, that's absolutely fine. If possible, could you take a picture and upload it with your with your worksheet for today? So the consolidation, facts. You have 4 minutes to write down as many facts as you can from this week's learning. So, not just from today, from the lesson on collision theory and today. So, for example, you might write down when particles react, they must collide. You might say increase in temperature can make a reaction faster. So, you've got 4 minutes. So, I'd like you to set a timer on your watch or your phone, or just look at the clock in the bottom of your screen. 4 minutes. Bullet point as many facts as you can. Once you have done that in 4 minutes, you then need to complete your end of lesson RAG rating. So, facts for 4 minutes, and then complete the RAG rating for the learning intention, red, amber, or green.